Hello everyone, Assalamualaikum warahmatullahi wabarakatuh. May peace be upon you. So, in the previous lecture video, we've learned about how to calculate moment in 3D using cross product, which is distance r in vector cross product with force in vector. Okay, and I also mentioned that when we want to calculate the moment in 3D, no need for us to make the distance to be 90 degree with the force. No need, okay, just like I've shown here, okay, in this figure here. Okay, so let's try to calculate moment. Okay, let's look at this question, this example here. The pole is subjected to a 60 Newton force. Where is 60 Newton? This one, okay, that is directed from C to B. From C to B. So determine the magnitude of the moment created by this force about the support at A. So means that we need to calculate moment A. Okay, so this one, moment A. Okay, we need to calculate this one. Okay, moment A. Okay, before I proceed to the solution, I give you about 5 seconds, okay, to pause the video and try to do it by yourself first. Okay, did you pause the video to do it by yourself? No, please pause the video, try to do it by yourself first, and then you can see the solution, and watch the solution after that. Okay, okay, so let's continue with the solution. Okay, now this question give us the value of the force in magnitude 60 Newton. I mentioned earlier, when we want to calculate moment, we need to use force in vector. So means that we need to change this force 60 Newton to a vector. Okay, so how to change a force into a vector? Okay, so first we need to find the direction first. Okay, we need to find the direction. So if you want to find the direction, we need to find the coordinate. So find coordinate first, and find the direction, and then find the magnitude of the direction. Then we can calculate the unit vector. Okay, unit vector is equals to direction in vector over the magnitude of the direction. Okay, then the unit vector, we multiply it with the force, okay, the magnitude of the force. Okay, so that is how we can change the force into Cartesian vector form or vector. Okay, let's do that first. Okay, now we have 3 points here. Okay, point A, point B, and also point C. Okay, so let's write down the coordinate for all the points first. So we have point A. So for point A, okay, it is 0, 0, and also 0 because it is the origin. And then we have force B. Point B, which is x direction is 1 meter. So 1, y direction is 3, z direction is 2. Okay, so coordinate for C is x direction is 1 plus 2, so 3, y direction is 4, okay, and z direction, no, okay, no z direction. Okay, so these are the coordinate for A, B, and C. So to change this 60 Newton here, okay, into Cartesian vector form, so we find unit vector. Okay, so to calculate unit vector, so unit vector from where to where? C to B. Okay, so if you look at here carefully, the force here is pointing from point C to point B. Okay, so which is why we use unit vector C to B. Okay, so let's continue with the calculation. So this one here is equals to R C to B in vector over the magnitude of R C to B. Okay, so to calculate R from C to B, we need to use coordinate B minus C. Not C minus B. Okay, B coordinate B minus coordinate C. So our coordinate B is 1 minus 3. So it will be negative 2i. And then 3 minus 4, negative 1j. And then 2 minus 0. So go 2k. Okay. Over, so the magnitude here is 2 square plus 1 square plus 2 square. This one. Okay. So if we calculate this one, we can get negative 2 over 3. 2 over 3i minus 1 over 3j plus 2 over 3k. To calculate the force, this one, okay, or to change this force into Cartesian vector form, as mentioned earlier. Okay, sorry, I need to reconnect this one up to here. Okay, so F C to B, okay, or F 60 Newton. Okay, so this one here is equals to unit vector C to B, unit vector small, multiply with the magnitude, which is 60 Newton. So we can get the answer is negative 40. Okay, correct? Okay, correct. 40i minus 20j plus 40k Newton. Okay, so now we've changed the force into Cartesian vector form. Nice. The next one, to calculate moment, okay, to calculate moment here, this one, MA here is must equals to R cross product with F 60 Newton here. So we've already have F here, and we need to find R. Okay, so what is the distance from where to where? Okay, so as you can see here, the force is pointing towards B here, and then the rotation point is at A, so we can choose RA to B. Okay, so write down RAB. So RAB is coordinate B minus coordinate A. So this one will be B minus A, 1I plus 3j plus 2k. So next we can calculate moment at A. So moment at A, is equals to RAB cross product with F 60 Newton. Okay, this one here will be I J K 1 3 2 negative 40, negative 20 and 40. Okay, so it will be, okay, so right now I've done the calculation. Okay, so here, okay, when we do the matrix calculation here, so first of all, this one is positive, positive I, but for J here, so make sure this one, okay, make sure you put negative for J. Okay, and then for K is positive again. Okay, for K is positive. So when we calculate it, so the answer will be 100. So now 160I minus 120J plus 100K. Okay, so 160I here. So this one is MX. So this one is MY. And this one is MZ. So let's look at the question again. Okay, here we want to find magnitude. Okay, we need to determine the magnitude of the moment. So this one is not a magnitude, this one is in vector. So when we want to find a magnitude of a vector, okay, regardless distance, force or anything, So we must use square root mx square plus my square plus mz square. Okay, just like how we want to calculate the magnitude of force and distance. Same, okay, that is how we calculate magnitude for a vector. The magnitude of MA, this one here, is equals to square root of mx square plus my square plus mz square. Okay, so here 160 square plus 120 square plus 100 square. So the answer, let's roll it. Okay, so the answer will be, so after we use the calculator, so we got the answer is 223.61 Newton meter. Okay, did you get it right? Okay. Okay. So in the next video, okay, in the next video I will show you about this one. Okay, about the distance and also the force. Okay, so if we use another distance, okay, right now we use A to B, yeah. Okay, so in the next video I will show you the calculation of when we use RA to C. Why RA to C? Because RA to C also actually is the distance from the rotation point until the line of force. Okay, because the line of force here is from this one, C to B. Okay, see you again in the next video. Bye bye.